Hello, I'm back. In this topic, I will discuss about irrational numbers. What do you mean by irrational numbers? First, the things you need to know. The square root of a positive integer is either rational or irrational. Second, if the radicand is a perfect square, then the square root is rational. If the radicand is not a perfect square, then the square root is rational. I think you already know what are the perfect square. Consider square root of 29. Using a calculator, square root of 29 is equal to 5.38514.807, which is non-repeating, non-terminating decimal. If that's so, 5.385164807 is an irrational number. Irrational numbers. When you say irrational numbers, are numbers that cannot be expressed as quotient of two integers. These numbers are non-repeating and non-terminating decimals. I hope you know already what are non-repeating and non-terminating decimals, because it is very useful in this discussion. Best example of an irrational number is pi. Pi is equal to 3.1415926535 and so on. The decimal numbers of pi has no end, and it is also non-repeated. When say non-repeating, I will just have a review for that. When say non-repeating, means that the numbers found in a decimal number are not repeated. When say non-terminating decimals, the decimal numbers has no end. Pi is an irrational number because its digits go on forever without repeating. Examples. Determine whether the principal square root is rational or irrational. Square root of 169. Since 169 is a perfect square, because why is it 169 is a perfect square? When you factor out 169, that is 13 times 13, and the result for that is 169. Square root of 169 is rational. The principal square root of 169 is positive 13. How about square root of 41? That is in example 2. Since 41 is not a perfect square, therefore square root of 41 is irrational. How about square root of 25? Is it rational? Yes, because 25 is a perfect square. When you factor out 25, that is 5 times 5. Square root of 25 is rational. Then the principal square root of 25 is positive 5. Example number 4. And that is square root of 81. Is square root of 81 is rational or irrational? What will be? Try to guess. Yes, square root of 81 is rational because 81 is a perfect square. When you factor out 81, that is 9 times 9. Therefore, the principal square root of 81 is positive 9. In example 5, that is square root of 11. Is it rational or irrational? Square root of 11 is irrational because 11 is not a perfect square.
Hello math learners! In this video, we are going to learn about how to estimate the square roots of a non-perfect square numbers. Now, to estimate the square roots of a non-perfect square number, we need to determine between what two integers the square root of a number is. And these are the steps to follow. Number 1, find two perfect squares which are close to the given number. Second step, or number 2, get the principal square roots of the two perfect squares. Now, let's apply these steps to the examples or to the following examples. Okay, example number 1. Square root of 23. We all know that 23 is not a perfect square, so we will estimate its square root. Now, how to find the square root of 23? First step, find two perfect squares close to 23. So, we all know that the perfect squares are 1, 4, 9, 16, 25, and so on. We need to find only two perfect squares close to 23. Close means the perfect squares before 23 and after 23. And these are 16 and 25. Now, for the second step, get the principal square root of the two perfect squares. So we need to get the square root of 16 and the square root of 25. We all know that the square root of 16 is 4 because 4 times 4 is 16. And the square root of 25 is 5 because 5 times 5 is 25. So that means 4 and 5. And square root of 23 can be found between these two numbers or between these two integers. So that means square root of 23 is a number between 4 and 5. Okay, now let's have example number 2. Okay, we have the square root of 50. First step, find two perfect squares close to 50. And these are 49 and 64. 49 is a perfect square before 50 and 64 is a perfect square after 50. Next, get the principal square root of the two perfect squares. Again, principal square root means the positive square root. So that is the square root of 49 and the square root of 64. The square root of 49 is 7. The square root of 64 is 8. So that means square root of 50 can be found between 7 and 8. So that means square root of 50 is a number between 7 and 8. Okay, now let's have example number 3. Square root of 150. Again, first step, find two perfect squares close to 150. And we have 144 and 169. Next, get the principal square root of the two perfect squares. Find the principal square root of 144 and find the principal square root of 169. And again, we all know that the square root of 144 is 12 and the principal square root of 169 is 13. So that means the square root of 150 can be found between these two numbers. So, square root of 150 is a number between 12 and 13. Hello math learner! In the previous video, you have learned how to estimate the square roots of the non-perfect square numbers. Now, in this video, you are going to estimate the square roots to the nearest hundreds. These are the steps to follow. Number 1. Find two perfect squares which are close to the given number. 2. Get the principal square roots of the two perfect squares. 3. Estimate by trial and error. The number should be found between the two principal square roots. Okay, now let's apply these steps to the following examples. Example number 1. Square root of 3. First step, find two perfect squares close to 3. And these are 1 and 4. Next, get the principal square root of the two perfect squares. And these are square root of 1 and square root of 4. Square root of 1 is 1, square root of 4 is 2. So, square root of 3 is a number between 1 and 2. Third step, estimate by trial and error. The number should be found between two principal square roots. So by trial and error means we need to think of a number that is found between 1 and 2 for us to solve the square root of 3. So we can think 1.1, 1.2, 1.3. These are the numbers that are found between 1 and 2. So let's try 1.5. By estimation, 1.5 squared, we will square the number. 1.5 squared means 1.5 times 1.5, and that is equal to 2.25. Let's try another number, 1.6. 1.6 squared is 2.56. Okay, it's almost 3. Now let's try another number, 1.7. 1.7 squared is equal to 2.89. Okay, and 1.8. 1.8 squared is equal to 3.24. Now, let's choose the numbers where 3 can be found. Okay, 3 can be found between this 2.89 and 3.24. So that means we will choose 1.7 squared and 1.8 squared. Okay, now let's continue the estimation. We will think of a number between 1.7 and 1.8 because again 3 is between 2.89 and 3.24. So let's try 1.71. Okay, 1.71 is between 1.7 and 1.8. So let's square this number, and that is 2.9241. Next, let's try 1.72. Squared is equal to 2.9584. Oh, it's almost 3. Next, 1.73 squared is equal to 2.9929. And let's try 1.74 squared, which is equal to 3.0276. As you can see, 1.74 squared is already a number after 3. So this can be cancelled out. This can be cancelled out. So we have only 3 choices. Which of these is the number closest to 3? We have this number, and that is 1.73. Thus, we have the square root of 3, which is approximately 1.73. Example number 2. Square root of 15. First step, find two perfect squares close to 15. These are 9 and 16. 9 is a number before 15, and 16 is a perfect square number after 15. Second step, get the principal square root of the two perfect squares. square root of 9, and square root of 16. And the square root of 9 is 3, the square root of 16 is 4. So that means that the square root of 15 can be found between 3 and 4. Last step, estimate by trial and error. The number should be found between the two principal square roots, 3 and 4. So let's think of a number between 3 and 4. Let's choose 3.6. 3.6 squared is 12.96. 3.7. 3.7 squared is 13.69. 3.8. 3.8 squared is 14.44. Oh, it's almost 15. Next, 3.9 squared is 15.21. Now, 3.8 and 3.9. These are the numbers, or between these two numbers, we can find 15, 14.44 and 15.21. So that means we will continue the estimation and we will think of a number between 3.8 and 3.9. Let's say, for example, we have 3.85. 3.85 squared is 14.8225. Okay, 3.86 squared is 14.8996. 3.87 squared is 14.9796, and 3.88 squared 15.0544. Oh, this is already after 15. So we will cancel this out. We have three choices. So which of these is the closest to 15? And this is this one, 14.9796. Thus, we have the square root of 15, which is approximately 3.87. That's it for this video, my math learners. And always remember, the only way to learn mathematics is to do mathematics.